How does Starlink satellite internet work? Welcome to Jumbo Digital Science Technology. Let's get started. Starlink is a satellite internet constellation developed by SPACEX, a company founded by Elon Musk. It aims to provide global broadband internet coverage using a network of thousands of small, low Earth orbit (LEO) satellites. Here's an overview of how Starlink satellite internet works. Satellite constellation. Starlink consists of thousands of small satellites in LEO, positioned around 550 kilometers, 340 miles above the Earth's surface. These satellites communicate with each other using laser links, creating a network in space. User terminals. To access the internet via Starlink, users require a user terminal, also known as a Starlink dish or phased array antenna. This terminal is installed at the user's location, such as a home or business. Signal transmission. When a user wants to access the internet, the user terminal sends a signal to the nearest Starlink satellite overhead. The signal travels at the speed of light. Satellite communication. The user terminal communicates with multiple satellites in the Starlink constellation. The satellites relay the signals to ground stations located around the globe. Ground stations. Ground stations are strategically positioned facilities that serve as the connection points between the satellites and the internet infrastructure on the ground. These stations receive the signals from the satellites and connect to the wider internet. Internet service provider. From the ground stations, the user's data is routed through the internet backbone, just like traditional internet connections. Internet service providers manage the flow of data and ensure its delivery to the desired destinations on the internet. Network optimization. SPACEX continuously optimizes the network to provide high-speed internet access to users. This involves adjusting satellite positions, optimizing the routing of data through the satellite network, and upgrading ground station infrastructure. Low latency. One of the advantages of Starlink is its low latency. Since the satellites are in LEO, the round-trip time for data transmission is relatively short compared to traditional satellite internet systems, which orbit at higher altitudes. This low latency is beneficial for real-time applications like online gaming, video conferencing, and other interactive services. Global coverage. The goal of Starlink is to provide internet coverage to even the most remote areas of the world. By using a large number of satellites in a distributed network, SPACEX aims to eliminate internet connectivity limitations caused by geographic location. Starlink and broadcast satellites serve different purposes and operate in distinct ways. Dishy McFlatface is a colloquial term used to refer to the Starlink user terminal or phased array antenna used in the Starlink satellite internet system. While specific technical details about the internal components of Dishy McFlatface are proprietary to SPACEX. An aperture-coupled patch antenna is a type of microstrip antenna that operates by coupling electromagnetic energy between two radiating elements, the patch antenna and an aperture in a ground plane. Electromagnetic wave emissions refer to the propagation of electromagnetic waves through space. Electromagnetic waves are a form of energy that consists of oscillating electric and magnetic fields that are perpendicular to each other and travel through space at the speed of light. Beamforming is a technique used to shape and direct electromagnetic waves, such as radio waves, in a specific direction to create a focused beam. It is commonly employed in various applications, including wireless communication systems, radar systems, satellite communications, and more. Steering and sweeping a beam across the sky involve the dynamic control and adjustment of the direction of a focused beam of electromagnetic waves. This technique is often used in applications such as radar systems, satellite tracking, astronomy, and wireless communication systems. Starlink, the satellite internet constellation developed by SPACEX, utilizes phased array beam steering to establish and maintain communication links between the user terminals, such as the dishy McFlatface, and the Starlink satellites. Phased array beam steering is a technique used to control and direct the transmission or reception of electromagnetic waves in a specific direction using an array of antenna elements. To send data to a Starlink satellite using a beam, you would need to establish a communication link between your transmitting device, such as a Starlink user terminal or ground station, and the targeted Starlink satellite. 6.4 QAM, quadrature amplitude modulation, is a modulation scheme used in digital communication systems to transmit data over radio waves or wired channels. It allows for higher data rates compared to lower-order modulation schemes like QPSK, quadrature phase shift keying, or 1.6 QAM. The actual size of the Starlink dishy McFlatface, also known as the Starlink user terminal, is approximately 48 cm (18.9 inches) in diameter. It is a compact and relatively small satellite dish designed to receive and transmit signals to and from the Starlink satellite constellation. As for the size of electromagnetic waves, it depends on the specific frequency or wavelength of the wave. Electromagnetic waves span a wide range of frequencies, from extremely low frequency waves, ELF, with wavelengths of thousands of kilometers, to extremely high frequency waves, EHF, with wavelengths as short as millimeters or less. Video created by Jithish Muthu. Powered by Jumbo Digital Science Technology. Thanks for watching.